Okay, well let's leave that assignment till tomorrow then, Rory. I want you to let's go through the review. You're on 5B, you said?
Yeah, there's 2B because I'm on the first B.
Sorry?
I said there's 2 B's on here. I'm on the first B.
Oh yeah. Oh, I never noticed that. Okay, do you want me to go through any of those questions with you?
No, they're all pretty straightforward. You just have to multiply the denominator by the numerator and then solve for x and get your modulus.
That's right. So it's not, yeah, there's not too much to it. Okay, so I need you to finish that. Well, finish that assignment for tomorrow first. That's got to get done.
Yeah.
Okay, and then I will go through tomorrow. I'm going to start that chapter 11 with you tomorrow, and we'll try and get it done by mid next week so that we can get back into some of your old assignments and look at those. Okay, so for tomorrow, make sure the chapter 9 assignment gets done.
Yep.
All right, and then tomorrow I'll go through exponential and logarithmic assignment with you, so you can mark it. Okay, and then I'll start the new stuff tomorrow.
Okay.
All right. No questions there. Physics. Did you do any of that assignment, that worksheet that I had given you?
I have a worksheet, yeah, but it's not bad. It just takes me a while to get into it. Like, not into it, but like
Yes.
figure it out.
Okay. So I went through the number 5 worksheet with you last week.
Yeah.
And you were okay on the number 2 worksheet?
Yeah, so far, it's not my favorite thing in the world. But
No. Okay, well,
fine.
all right. Same thing. Let's go through, look at the answer, the one that says answer key at the top, on the top right, that chapter 19.
Okay.
So we did questions 1 and 2 on there. Let's go through the back side of that sheet right now. I want to clean this up tomorrow as well. So I'm going to ship you an assignment tomorrow on this. I think it's about 6, 7 questions that you'll have till Monday to get done. And then I'm gonna get the new section ready for you on momentum. So because you guys don't have the textbooks, I'm gonna have to photocopy and scan it and send it to you.
Would I be able to get my mom to pick it up?
The textbook?
Yeah.
That would be the easiest way to do it, yeah.
Okay, I'll text her right now.
Okay, well, you know what? I'll get one for your mom, but I'll also put textbooks out in front of the school for, it doesn't matter. I have to scan it anyways because Mary can't get it, neither can Petra, and Eli. So I'll have to scan them and send them to them. So your mom can grab a textbook for you.
Okay.
Okay, so let's look at question 3 on the worksheet. It says it has a little number 5 at the top. It says part B continued. Do you know what that is?
The number 5 at the top. Yeah.
It says question 3. So the question says a conductor 40 centimeters long.
Yes.
You there?
Mhm.
Okay, I want to go through that whole worksheet, that side of the worksheet with you.
Oh God. Okay.
All right. I mean, we don't have to go through every question, but let's go through most of them. Okay, so a conductor 40 centimeters long has a mass of 15 grams. So length, four meters, mass 0.15 kg, lies in a horizontal position at 90 degrees to the field lines of a uniform horizontal magnetic field. .2 Tesla. What must be the current in the conductor? What must the current in the conductor be? So I'm looking for I. So that the magnetic force on it will support its own weight. So the force has to support its own weight. So we take M times G. So we take the mass, so 0.015 times 9.8. The force is equal to BIL. My equation sheet to make sure that's right. Yeah. Okay. So to get the current, force divided by BL. Force is 0.147. B is 0.2. And L is 0.4. Okay.
0.838.
Yep. Weight. So that's where the mass comes into it. F equals BIL is just the maximum. The other one that we use is F equals BEV, where we have the charge on an electron or a charge and the speed at which it's traveling. So
when it's saying it supports its own weight, you just have to multiply it by the force of gravity.
By the acceleration of gravity, yeah, it's mass. That's right. Okay. Any questions about that one? We're okay?
No.
All right. There's a current of 4 amps in a circular loop. Okay. Wire with a radius of 0.15 meters. How many magnetic lines of flux are in an area of 4 centimeters squared? Okay. Located at the center of the loop, lying in the plane of the loop. Okay. So we have a circular loop of wire with a radius 15 centimeters. All right. So let's go to our formula sheet here. I need to find a separated one. Okay, so looking at my equation sheet, I've got I, I've got R, I've got A, and I am looking for magnetic lines of flux. Okay, so I need that from that information. Okay, so now I have to find my B. And my B, my flux density, can be found by taking 2 Ki over R. So the flux density is found by taking 2 Ki, where I is your current in amps and your radius in meters. So I get my B first, and then I use that. I have to convert 4 centimeters squared. I'll have to convert that to meters squared. Okay, so I've got 2 times 1 times 10 to the negative 7 times a current of 4 over a radius of 0.15. So we'll figure that out first.
The screen just went really blurry. I have to go out and come back in again quickly.
Okay, go ahead.
Or else, sorry.
Okay.
Okay.
Good.
Wouldn't because the formula that I'm looking at, it uses the diameter, not the radius.
Ooh, some nice feedback. Which one is using the diameter?
Oh, this is the one where, oh, just kidding. I have 2 sheets in front of me.
Okay. Okay, so I got 4 centimeters. I'm going to divide that. I'm going to change that to meters squared. So that's 100 by 100 would be 10,000, right? That would be in Weber's. Okay.
Yeah.
All right. So again, the one thing that we do a lot of in this is mix and mingle those equations together in order to solve them. So you'll notice that, you know, we had to find that B equals 2KI over R before we found B equals the magnetic lines of flux divided by the area. All right. Okay. Magnetic field strength in the air core of a solenoid is 1.5 times 10 to the negative 2 Teslas. So my B if the solenoid is 10 centimeters long, and has a current of 2 amps, how many loops of wire? So I need the number of loops. Does the solenoid have? Okay, so you look at the bottom of the page. There's one very specific for the solenoid. That's your B equals 4 pi K I N over L. So I need the N by itself. So I get B times L over 4 pi K I. All right, so all we have to do in this question is just arrange that differently. Okay, so I've got 1.5 times 10 to the negative 2 times 0.1 bracket 4 pi 1 times 10 to the negative 7 times 2. Okay, I don't need all those brackets. It's just easier to write with brackets. I only need the one set on the bottom. So I go 1.5 exponent negative 2 times 0.1. I'm going to divide that, open the bracket, 4 pi times 1 exponent negative 7 times 2, close the bracket, and I get so that wire in that solenoid, in a 10 centimeter wire, 10 centimeter long solenoid, you would wrap that wire around 596 times. which would be a lot in a 10 centimeter area. Okay. You follow that?
Yeah, I did. That one was kind of pretty straightforward.
Okay. All right, let's do a couple more then. Let's do 6 and 7. An alpha particle, the charge 3.2 times 10 to the negative 19, a mass 6.7 times 10 to the negative 27, accelerated through a potential difference of 1200 volts, and then enters a magnetic field of 0.25 Teslas. What is the magnetic force acting on it? Okay, so I need the magnetic force. I'm given the field strength of 0.25 Teslas. All right. It is, I've got a potential difference of 1200 volts. So this is the question. We did this question on one of the other sheets. So this question is tricky because we have to use work and kinetic energy. Remember to find the velocity. All right. So I've got a charge. My Q is 3.2 times 10 to the negative 19 coulombs. I've got a mass 6.7 times 10 to the negative 27 kg. Okay. And so in order to get my force is BeV or BQV. I put E there if it's an electron. V is the velocity. So I need to find the velocity from this question. So this is the one where I said, okay, work was equal to, oh, we had a mess of this. Do you have that question somewhere? Work was equal to kinetic energy, and Q times V was equal to 1/2 mv squared. I believe that was right. All right, so to get my velocity, I have the square root of 2 times my charge times my voltage over the mass. Okay, so square root 2 times 3.2 exponent negative 19 times 1200 divided by 6.7 exponent negative 27. Our velocity was 338,565.9 meters per second. And then I use that. Need the one on the left there.
Which one?
This guy right here.
Sorry.
That's okay.
Oh, this one.
Yeah. Okay, thanks.
Yeah.
You going home?
Yeah.
Okay. Okay. So that's what I end up with there. Now I just substitute that into my force formula with B and Q now. So B is 0.25 times my charge, which is 3.2 exponent negative 19, times answer, and I end up with a force of 2.709 times 10 to the negative 14 newtons. Okay, so this was the same question that we did on that other worksheet, in which we had to add those together, my work and my kinetic energy. And like I said, we'll start doing some work and kinetic energy stuff after the fact here next week. All right. That should be good. Question 7 is the same question as the other worksheet as well, with the 2 parallel lines and the X and the 2X.
Okay.
Okay, so what I'm going to do is I will put an assignment out Well, I'll let you work on math today. Finish off that assignment, and then I'll put a physics one out tomorrow for you, but you'll have 3 or 4 days to do it.
Okay.
All right? So any questions from physics or pre-calculus right now? Did you look at that assignment yet? That's due tomorrow.